So those of you who weren't in class today, here's the answers to 9, 11, 13, and 15. All right, so what are we going to do today? We're just going to add on to this just slightly. There's going to be one thing that blows your mind, and then after that should be just fine. So we're doing 2.2b, so we're still working with period. Now, the thing that's going to blow your mind is this. Let's say that instead of y equals the sine of like 2x, we're going to say sine of pi over 2x. Ooh, that's weird. Remember yesterday, but last time we were together, it wasn't yesterday, but hey, it was Tuesday, that my period equals 2 pi over b, and this was b. So my period here is going to be 2 pi over 2. That's a complex fraction, right? So if I multiply by the denominator, I'm going to multiply both the top and the bottom by 2. So my period is going to be 4 pi over pi. And if my pi's cancel, my period is going to be 4. Just regular number 4, not 4 pi. Not anything to do with pi. So when we would graph something like this, oh, come on, Mr. Bierschbach, draw. Boom. If we graph something like this, that totally changes our x-axis. So our period's going to be 4 long. So instead of doing pi over 2, pi, 3 pi over 2, and so on, we're going to do 1, 2, 3, 4. Just normal numbers. And I'm not going to graph my original function of sine equals sine of, or y equals sine of x. I'm just going to graph my final answer here. What's my final answer? Well, it's going to have a period of 4, so it's going to end at 4. Remember, sine starts at 0, 0, and it goes up, then it crosses, then it goes down, then there. So obviously at 1 should be the high point, and 3 be the low point. And this is a graph of sine equals pi over 2x. Okay? So, let's say now, I'm going to get even meaner on you. Y equals the sine of pi over 4x minus 3 pi over 4. Well, before I start the problem, this is not b. b happens on the outside of the equation, so y equals sine. We have to factor out pi over 4 from the inside. So if we factor out a pi over 4, what's left on the inside? X minus 3.
Excuse the interruption. Nobody Jared Tasky. Please come to the office.
All right. So what I'm going to graph first is y equals sine of pi. Come on. Y equals sine of pi over 4. Then I'm going to graph y equals sine of pi over 4 minus 3. And you'll see what happens. The minus 3, since it's inside the parentheses, where's it going to move it? To the left or to the right? Or up or down? It's going to go to the right by 3. Okay? So you got to think about this. Let me do my period now. My period is going to be 2 pi divided by pi over 4. So complex fraction multiplied by my denominator and my denominator. So it's going to be 8 pi over pi. So it's going to be 8. So you need to go at least 8 on your x-axis plus another 3 on your x-axis. Okay, so that's planning ahead when you're making out your graph. My computer is just being a little mean to me. All right. So I need to go at least 11. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll just put 12 down for extra measure. 1, 2, -1, -2. All right. So my period, are you kidding me? Jeez. My period's going to be 8 long, okay, when I'm graphing y equals sine of pi over 4. So sine starts here at 0, 0, and I'm going to end it at 8. Halfway in between, it's going to cross the x-axis. Halfway in between 0 and 4, where's it going to be? 1, which is x value of 2, but it's going to be 1 up. Okay. Halfway in between 4 and 8, which is 6, where's it going to be? -1. So it's going to be like this. Okay. Then my final graph is going to be 3 to the right. So go right by 3, which is 6 squares. Right by 3. Right by 3. And right by 3. So your graph should look like that. Okay. Now, besides those quirky looking ones, we'll have normal ones too, where we won't have pi involved in it. So we'll have normal ones today, like y equals -1/2 sine of 2 times x minus pi over 2 plus 3. Okay? So let's see if we can do something like this. Okay. When we make this out, I see that I'm going up 3. So I'm actually going to make this a little lower. So I have enough room to go up by 3. Okay. I'm going pi over 2, which direction? To the right. The 2 is going to do what to it? Shrink it horizontally, so I don't have to worry about putting things too far out. And what's this going to do to it? Flip it across the x-axis and shrink it. So let's go 1, 2, 3, 4 this way, -1. And then, since it's shrunk down, I want to go at least 4 to get to pi over 2. And 4 to get to pi. And 4 more to get to 3 pi over 2. And 4 more to get to 2 pi. All right. Boom, boom. All right. So, what I'm going to graph first is y equals sine of x. Where do I start sine of x at? 0. Then I'm going to go 1, 0, -1, 0. Then I'm going to graph y equals -1/2 sine of x. What does that do to the graph? Takes your y values and multiplies each of your y values by negative 1/2. So we're at 0, negative 1/2, 0, 1, 0. Okay. Then, now what do I do? Well, it's a 2 here. So multiply all your x values by 1/2, since that's a 2. So y equals negative 1/2 sine of 2x. So we start at 0. Instead of going over 4, we go over 2. Instead of going over 8, we go over 4. Instead of going over 12, we go 6 and 8. Now, we're going to subtract pi over 2 from that. So y equals negative 1/2 sine of 2 times x minus pi over 2. So everything goes pi over 2 to the right. How many squares is pi over 2? 4. So I just take the purple one and move everything over 4. And last but not least, I add 3 to it. There we are. Okay, so what we're doing today is making our axes different if we have pi over 2 that we're going to, or pi over something that we're going to factor out. Then our axes are going to be normal numbers, and you're going to work with that. If it's a normal number, then you're going to do what we did for today. Okay? Okay. So, yeah. This is the last problem. So, your assignment will be on page 127, 19 through 25, the odds. So, page 127, 19 through 25, the odds. All right, there you go. So we're only doing one lesson today. We'll only do one tomorrow.